How many exact units must a business sell to stop losing money and break even, using only the sales price, the variable cost, and the fixed cost? Let's look at a specific product. We are manufacturing these 1950s replica pop dance jackets. The standard sales price per jacket is £55. The variable cost to make one is £25, and the fixed costs for the process are £25,000. This shows the two foundational formulas required to solve this. First, contribution, which is sales minus variable cost. Second, the break-even point, which is the total fixed cost divided by that contribution. We start by substituting our jacket values into the first formula. We take the £55 in sales and subtract the £25 in variable cost. That isolates our unit contribution at exactly £30 per jacket. Now we apply that to the second formula. We divide our fixed cost of £25,000 by our £30 contribution. The result is 833.33 units. Identifying the unit contribution provides a clear baseline for how much each sale actually contributes to the company's bottom line. Once you know this margin, calculating the volume needed for any break-even scenario becomes a straightforward division. We can expand this formula to calculate the volume required to hit a specific £10,000 profit, rather than just reaching the break-even point. The target profit is added to the fixed costs in our formula's numerator. 25,000 plus 10,000 gives a £35,000 numerator. Divided by our £30 contribution, we target 1,167 units. In this calculation, the profit goal is treated as an additional burden that must be cleared by unit contributions, just like a fixed cost. Consider a scenario where a customer offers £22 for a one-off order. This looks problematic because the standard cost to make the unit is £40. Standard costs: £10 materials, £15 direct labor, £15 fixed overheads, plus a £2 special design. Labor and overheads are fixed, so we strike them. Relevant costs: 10 materials, 2 design. Subtracting this 12 from the £22 offer yields £10 incremental contribution. Relying on standard absorbed costs for one-off decisions can lead to rejecting orders that would actually increase the company's total profit. By isolating only the costs that change, the true contribution becomes clear. Now, consider a situation where production is limited. We manufacture 2 types of chess sets, but we only have 20,000 labor hours available. When resources are limited, you cannot rank products by their unit contribution alone. You must determine which product generates the most value per hour of that scarce resource consumed. Nimzo's £35 contribution over 3 hours yields £11.67 per hour. Rue Lopez takes 4 hours for the same contribution, yielding £8.75. Nimzo generates more value per hour, making it the profitable choice. To maximize profit in a constrained environment, the contribution must be tied directly to the bottleneck. There are times when management needs to see the break-even point in total revenue rather than units. This is where we use the contribution to sales ratio. We find the ratio by dividing the contribution by the sales price. In this example, £60 divided by 300 gives a ratio of 0.2. We then divide our total required contribution by that ratio to find the target sales value, in this case, £4.2 million. This grid summarizes the core mechanics of marginal costing, calculating break-even units, target profit volume, break-even revenue, and ranking by scarce resources. While management accounting involves many qualitative factors, these 4 formulas provide the quantitative foundation needed to evaluate the relationship between volume, cost, and profit.